Hello, everybody. Today we're going to be discussing what is the empirical formula. As you can see here, it is defined as the simplest whole number ratio of the atoms or moles of elements in a compound. I have another way to define it. I'm going to give you an example. This formula you may have seen before. Let me go ahead and rewrite it. It's glucose. It's a sugar. And perhaps maybe in biology, you know that it's been written like this, C6H12O6. That is the actual molecular formula of glucose. However, if I asked you to reduce this formula, you can easily see that the subscripts are divisible by 6. If we were to reduce this, you can divide everything here by 6, and you would get a 1 here, a 2 here, and a 1 here. In other words, you'd get a 1 to 2 to 1 ratio. Okay? Now, the reduced form, and again, we don't have to put the 1s here. We could just write it like this. The reduced form of the molecular formula is what is called the empirical formula. That's why it is defined as the simplest whole number ratio, but you can think of it as the reduced form of the molecular formula. Now, a way to determine empirical formula is by analyzing elements based on perhaps they give you the percent composition of each element in the compound, or another way to determine the empirical formula is if they give you the individual masses of each of the elements contained in the compound. Now, with that information, you can, in just a couple of steps, you can figure out using that analysis to determine the empirical formula. If you look here, the data can either be given to you in percentages, okay, and the data can also be given to you in grams. So the data is either one or the other. The first step really, and you could see here as step number 2, but the actual first step is to get the data and to convert everything into moles. So if the data is given to you in grams, all you got to do is divide by the atomic mass of each individual element and change all the data from grams to moles. If the data is in percentages, remember that percentages add up to 100%. So what we do is we're going to assume that the compound is a 100 gram compound. For instance, 40% of 100 grams would be 40 grams. So if they give you the data in percentages, all you got to do is get rid of the percent sign and just put a G for grams in its place. And then by getting rid of the percentages and converting them all to grams, you just do like the others and convert it back to moles. Okay, you're back to step 2 over here. So the data, your first objective is to get the data and change it from grams to moles. Now, after you do that, and you've converted them all to moles, then what you're going to look for, and really this is the second step, the way I teach it, is find out which of those moles is the lowest number. Okay, once you determine which is the lowest number of moles, you're going to divide all your answers by the lowest number of moles, and you're going to get a number. Okay? And here's the beauty of this. If those numbers are whole numbers, you're basically done. Okay? That will give you the subscripts of the empirical formula. Now, I'm going to walk you through these steps in just a moment. Sometimes, however, you have to do this extra step here, which is step number 5. After you convert to moles and you divide by the lowest number of moles, you might not have a whole number. Maybe the number ends in 0.5, okay, or 0.25 or 0.33. Well, if that's the case, we're going to have to do an additional step. And there's a key here on how this step works. It depends on the decimal. You're going to see that if a number ends in 0.5, what you're going to do is you're going to multiply by 2, and that makes it a whole number. If a number ends in 0.33 or 0.67, you're going to multiply by 3 to make it a whole number. If it ends in 0.25 or 0.75, you multiply by 4. You might sometimes have a scenario where it ends up at 0.20 and you multiply by 5. Usually, it's either scenario A, B, or C, okay? The beauty is, if they're already all whole numbers, as you can see in step D here, you can skip this step because you're actually done with the problem. Now, I'm going to walk you through all of these steps. In our first example, they're telling you that you decompose the compound. They tell you the elements of the compound, and here's the data. This compound has 2 elements, nitrogen, and they tell you it's 24.5 grams of nitrogen, and oxygen, which is 70 grams. Now, in this example, the data is in grams. So, step number 1, okay, and again, I'll walk you through it. Convert grams to moles. So what you're going to do is you're going to go to the periodic table. You're going to find the molar mass of nitrogen. We're going to round it to 14.01, okay? And you're going to divide that and get it into moles. Do the same for oxygen. 70 grams. The atomic mass of oxygen is 16. So notice I'm dividing each by their respective atomic masses. Well, first, for nitrogen, you get 1.749 moles. For oxygen, you end up getting 4.375. I usually round around this area. You don't have to keep leaving any extra digits. This is good enough. Now, we are ready for basically the second step. Once you convert everyone to moles, which we did, identify which of those 2 numbers is the lower of the 2. Clearly, this one is. So here's what you do in step 2. Divide each by the lowest number of moles. So I'm going to divide this by 1.749, and I'm going to divide this also by 1.749, because that's the lower number of moles. Here you're going to get a 1. Here you get a 2.5. Now, listen carefully. Had both of these numbers been whole numbers, we're actually done with the problem. But we're going to have to do an extra step. If you recall, one of the numbers ended in 0.5, the one that says 2.5. Look what it says here. Okay, multiply all by 2. So let's go back to the problem. Since this ends in 0.5, in this case 2.5, the rule says that we need to multiply by 2. Now the key is, whatever you do to this number, you must also do it to the other number. What you do to one, you do to all. So we're going to have to multiply both of them by 2. When you do that, 1 times 2 is 2, and 2.5 times 2 gives you a 5. These are now whole numbers. Believe it or not, we are done with problem number 1. The numbers that I just circled are the subscripts of the empirical formula. So notice, in this compound, there are 2 nitrogens, so you put a subscript here, and there are 5 oxygens, and that is our answer to our first sample problem. Now, what I did here in the video is, this one is worked out for you. You could see here step number 1, them converting grams to moles. Here in step number 2, they're dividing by the lowest of the 2. They rounded it to 1.75, which is fine. And then over here, they had to multiply by 2 because of this. Here's another chart over here. When a number ends in 0.5, like right over here, you multiply by 2, and that's our final answer. Okay? Let's try another. This time, I'm going to give you the data in percentages. Now, I don't know if you were paying attention earlier, but if the data is in percentages, assume that this is a 100-gram sample. You see, that data will add basically to 100%. So instead of saying you got 60% carbon, you're going to say you have 60 grams of carbon. The same thing with hydrogen. You got 4.48 grams of hydrogen, and then you got 35.53 grams of oxygen. So change them all to grams. Now let's go to step 1. We're going to divide each by their respective atomic masses. In the periodic table, you'll notice carbon is 12.01. Our goal is to convert everybody to moles. Hydrogen's atomic mass is 1.01 when you round, and oxygen is 16. So I'm doing step number 1. I'm dividing everybody here and changing them to moles. I get 4.996 moles here. The next one is 4.436 moles. This one is 2.221 moles. So once I change everyone into moles, then identify who's the lowest number of moles. It's the third number. And then once you identify who the lowest is, which is 2.221, divide everybody by the lowest, just like you see me doing here. When you do that, this gives you a 2.25. This one gives you 1.997. That's basically just 2.0 or 2. And this one is just 1. Now, notice this number. Had all numbers been whole numbers, we would be done. If you recall from our previous chart, if a number ends in 0.25 or 0.75, what you need to do is you need to multiply everybody by 4. Okay? So if I get 2.25, okay, and this is for carbon, and I multiply by 4, I get a 9. Okay? Hydrogen is 2 times 4. That's going to give me an 8. And then my oxygen was a 1 times 4. That's going to give me a 4. And these are going to be my subscripts. So my final answer to this one is I have 9 carbons, 8 hydrogens, and 4 oxygens. That would be my empirical formula for this problem. Now again, let me have you look at the solutions. So notice how they changed everybody to grams over here. Then this is step 1. They're changing everybody to moles. Okay. Then in the next step on the next page, they're dividing by the lowest number. Notice how everyone gets divided by 2.221. And you get this ratio. And because of that 2.25, we have to multiply by 4. Here's the 0.25 over here. Here is what you need to do. And when you multiply by 4, you get your final answer. Okay, so hopefully seeing this a second time is a little bit more helpful. Now I got one more. This one's a little interesting. We got to do a little extra. You have a 3.24 gram sample of titanium. So let's put that down. Titanium is Ti, and we have 3.24 grams of titanium. Now it's reacting with it's going to react with oxygen, and it's going to form something called a metal oxide. Now the mass of the entire compound, the metal oxide, is 5.40. That the metal oxide is titanium plus oxygen. Okay? So, in order to find the empirical formula, I need the data for titanium, which I have from the question. But I also need the grams of oxygen. So here's what we got to do. We got to do an extra step. We know that the compound has a mass of 5.40. And we know that this compound consists of titanium and oxygen. So look what we're going to do. When you subtract 5.40 minus 3.24, the difference is going to be the mass of oxygen, which is 2.16 grams. Notice that 2.16, which is the grams of oxygen, plus 3.24, which is the grams of titanium, adds up to the mass of the sample. So now we're back to square one. We have the grams of both elements. So our first step is always change to moles. So we got to divide by the atomic mass of titanium, which is 47.87. Oxygen from the periodic table is 16. Let's change them both to moles. This one is 0.06768. This one comes out to 0.0 1, 3, 5. These are both moles. Once you convert everything to moles, the next step is to divide by the lowest number, which happens to be this first one up here. So I'm going to divide both numbers by 0.06768. This is going to give me a 1, and this one gives me a 1.99, which is basically a 2. Now, I have great news for you. We don't have to do any extra steps, because if after you do the second step where you're dividing by the lowest number of moles, if the numbers are already whole numbers, you are done. So the empirical formula here is there is 1 titanium and 2 oxygens. In chemistry, the ones don't have to be written, they're understood. So you could simply write it as TiO2, and that is our final answer. Here it is worked out for you. Okay, there's the data given. Here is how they found the mass of oxygen by subtracting 5.40 minus 3.24. And then here's step 1. Everyone here was converted to moles. Okay, so that was done there. They used 47.88. I used 47.87. It depends on which periodic table you use. You're going to get the same answer regardless. Here, once you convert everyone to moles, here they divided by the lowest number. They rounded it a little different. Okay, but clearly when you do the division here, you got 2 whole numbers, so you didn't have to do any extra steps, and there's your final answer. Notice how they even tell you the last step is unnecessary because they are whole numbers already. Okay? Now, here's what I want you to do. I have 3 sample problems that I want you to work on. Okay? The first one is Skill Builder 6.10. This is similar to example number 1. So if you get stuck on this, go back and refer to example number 1 so you can figure this one out. The second, Skill Builder 6.11, is similar to the second example where the data is given in percentages, and Skill Builder 6.12 is similar to the one we just did, which is one where they give you the mass of a compound and you might have to do a little subtracting to find the missing data. Okay, so you have all the data for all the elements needed to do the calculation. So I want you to try these samples, and then we will go over these 3 in class to see how you did.